My name's Todd Rinaldo. I work at cPanel. One of the things cPanel is known for within the Perl community is that we take Perl scripts and we compile them into binary format so that they can be run. That is the reason why we still run Perl 5.6.2 in some cases. We do that because it reduces the startup time and the runtime of the Perl script to, the startup time of the script to near zero. So this whole project of compiling Perl scripts into binary started back in 1995 when Tom Christensen sent an email to Perl 5 porters offering a bounty for anybody who could do this. And if they did, he offered them a laptop, to which a person, I'm not sure who it was, replied and asked, well, what kind of a laptop? To which he offered them a 100 megahertz laptop with 32 mega RAM. But I think it's about 20 days later, Malcolm comes back from vacation and says he's been thinking about it and has figured out how to do it. It's how we still do it today. He effectively freezes the run state of Perl just before it starts running. You take that, you pump it out into a C program, you compile it into a binary, link it to libperl, and then when you run the binary, it reloads that running state and then just hooks into libperl just like normal. I talked to Malcolm recently and he says the laptop is sitting around there somewhere, but I couldn't coerce him into sending me a picture of the laptop. To understand how to do BC, you have to understand a little bit about the different run states of Perl. So there's some special states you can do to make sure the code runs at certain points in the Perl program. This is straight out of the Perl mod documentation. So you have a begin block, which we use a lot when we want to make sure that code is actually compiled into that binary before it actually runs. There is a unit check which runs at the end of the file being loaded. So if you're loading a PM file, at the end of loading and executing anything it needs to in that PM file, it then comes back and runs all of the unit check blocks. We don't really have much use for that. And then you have the check block, which is actually where BC hooks. O.PM creates a hook so that it's the last check block that's run that actually allows BC to do the compile, or generation of the C code is all BC does. And then you have init blocks, which we use, that allows you to, anytime you rerun that binary you've generated, those init blocks are going to run. And then finally you have the end block, which runs at the end of the program. That doesn't have much to do with BC. So this is also out of the same document. And you can see the numbers are kind of out of order, but if you were to run this program, you would get 1 through 16. And that's just because as it parses it, the first thing it's going to do is find all the begin blocks, execute those, so you got 1 and 2. It's going to come back and it's going to run unit check, so you have to go upwards in the file. So 3 is down here at the bottom, and I'm not going to be able to find all these. There's one up at the top, number 4. Then after the entire program compiles, it's going to come back and run the check blocks, also going upwards. The program then runs, so all just your normal print statements are going to run. Did I miss a state? Yes, you've got the init state, which then goes top to bottom. So you've got 7, 8, and 9. And then the program runs, so you've got just your normal print statements, and then finally the end statements, which, are they last in, first out also? Yeah, so 16's at the top, which is your last one. So there's 3 modules you need to know about with respect to the Perl compiler. You've got BPM, which it can kind of be thought of as the unofficial API to Perl. It's unofficial because we don't really have any documentation on it. So it's what allows B to go, or BC to go in and look around, figure out what variables exist in the system, what op trees or what compiled subroutines exist, and freeze the state of that information. Then you have OPM, which if you run Perl with OPM, what it does is it puts that program into check mode. So it's not actually going to run the program, it's going to stop just before a nit. And then it creates a check block that runs last, which just calls B whatever compile, and it actually passes some information so you can actually capture standard in and standard error if you need to provide that to whatever compiler backend in order for it to do its thing. So then BC receives it. So here's a real example of what happens. You would do -mo equals cc. The QQ is how you tell it how to get standard error and standard in passed into the compiler in the check state. -03 is an optimization option that you're simply passing into BC. -O tells you where to generate the C code, and then the program itself. Okay, so one of the biggest things that people get into trouble when they first start working with compiled scripts is file handles. So if you run, if you put certain code, for instance in this state, if you open a file handle in a begin block and then later in the code you use it, any normal Perl script that would be just fine, there would be no problem. But if I were to compile this, all of the information that happens in the begin state is going to be captured into the binary, which means when you get to sub later and you run that, the program's going to blow up. I'm not sure if it's seg faults, but it's definitely not happy about it. And of course, this doesn't normally happen in our code, but what happens is we load a CPAN module or update a CPAN module, and it's doing something like this, and that gets us into trouble. So those are actually pretty easy to detect and fix. What we actually struggle with is things like this, where we had IO socket SSL. He did some optimizations to it, and he needed to use he had to, in the begin block, open a handle to libSSL in order to do some, I think it was Diffie-Hellman initialization. Let's see if I can get to that. Oh, great, I have to back out. Okay, I'm not going to read that here. Where it had to do some Diffie-Hellman optimizations, and then later it would try to use that, and we had programs seg faulting over it. So what we did is we had to fix those. We actually created init blocks in that module and patched it so that it would zero out that handle, so that later at initialization we could reinitialize those handles. The problem is most CPAN authors don't want an optimization like that. There's very few people who need it. So there's a lot of confusion when I talk to people about perlcc who think that by doing that it's going to actually make their program run faster. And if you have a long running process, perlcc is really not going to help you that much, because it doesn't speed it up. All it's done is taken that, it's sped up the startup cost of that program, but once it's running, it's just running with libperl just like normal. There's no value whatsoever to using BC for that purpose. Out of the box, you typically are not going to be able to statically compile XS. So when perlcc sees that you've loaded some XS modules, what it actually does is dynamically link that straight to your binary. So when you ship your binary, you also have to ship the SO files that go with it. In cPanel's case, we have a Perl distribution that we ship with our product, so we always know exactly where our SO files are. It's not a big deal for us. It does happen that in any Perl module that you're building, there's a make target where you can actually generate the .a file, and it puts it right next to the SO file in your Perl tree. And if perlcc sees that, you can actually tell it to statically compile against that, in which case you can actually ship without the XS. Now I'm going to make a promise here, and I don't actually know if this works with the Perl distribution. Normally you generate libperl.so, which is a shared library. Normally you would have to ship this with your binary in order to get it to work. In theory, you can actually build Perl with a .a file, and therefore you could actually link that into your binary and you would have a standalone binary. Okay, so what BC can do. So it speeds up the page hit of traditional CGI apps. And I have a simple example I'm going to show you. I chose not to do this over the internet because I thought that might be a bad idea in a time presentation. So this is on my sandbox at work. It's just a very simple app that displays a default web page with some information. It's actually using Template Toolkit and some other things. So it's fairly large. In this case, I generated a .static file which we use to portably ship stuff around. Except we don't actually include any cpan modules when we generate static files. Those are just supposed to be internal code at cPanel that we ship around so that we can just run that as standalone. And it's supposed to be that you only do that when you're building something that just requires core Perl. But you can see it's 26,000 lines of code, of cPanel code, just to ship that, plus the cpan code. It's a fairly large program. Up top, you see the .cgi file. That's a 5 meg file that I compile, which is the compiled version of this. And we wait a minute. Okay, so this is me actually doing make on that binary to show you what it looks like. In our case, we did some optimizations and we're doing V2, so you're getting a little more output about what's going on. We always get this one. I don't know what that's about, but it doesn't hurt the program. And it's 22 seconds to compile that. Okay, and then we'll move over. And what I'm going to show you is to show you the difference in performance. I'm using AB binary from Apache to show you the difference in performance. The first one we're going to do is a uncompiled binary. So I'm doing 1,000 page hits, 5 concurrently. And I'm going to show you how long that's going to take. Okay? So keep an eye on how long the request complete so you can see the performance difference. It's noticeable. Okay, so that was our uncompiled version. So it was 97 milliseconds for 50%. Now I'm going to do the compiled version. And you can see it's going a little bit faster. Okay, so this was 29 milliseconds for 50%. I don't know how this is going to show up on the screen. No, I can't. It's a video. Okay, so actually I have to back up 1 second. Okay, so you can see that even at 98% of our stuff, it was 39 milliseconds on page hits versus 98% up top, it was 114. So it was about a 3 times speed up to be able to do this. And this is a very simple example. We have much more complicated programs where this would look much worse, actually. I think that was all that was in that video. Let me make sure.
You mean the compiled version would be much faster?
Correct. The compiled version would be much faster is what I mean by much worse. Okay, that's it. Okay. Okay, So the other thing it does is shrink your program size. One of the optimizations we had to do for cPanel code is we were generating C files that were so big that on 32-bit systems we would hit GCC's 2 gig limit on compiling a program and it would crash. So what we did to fix that was we would walk the tree and pull out packages that were clearly not being used anywhere. And when we did that, we went from taking 40 minutes to compile some of our programs to 4 minutes. The other thing we did, and this is an optimization, so that's a recent optimization we did that's in the BC that's on cpan. The other thing we did was copy on write strings. So when the compiler builds a string, it just builds it as a normal C string without the overhead of a normal Perl variable. And then when you go to use it, it's going to duplicate it into a normal SV and use it. The other thing it's doing is it finds if I have 5 strings that are I am a jelly donut, it's actually only stored in the binary once with just 5 pointers pointing to it to take up less space. It's also giving you the perfectly sized arrays and hashes so that if I have a hash that is taking up 20 spaces, I don't know the algorithm, but that in theory could be taking up 40 or 50 hash entries in order to have my 20 space array, and in this case it's going to be exactly 20. So it is supposed to reduce your Moose startup time to 0, but as of the recent release of this module, this logic broke, and the package optimization I talked to you guys about, where it pulls out modules, it has to inspect ISA, and it's getting confused on Moose. The great thing about working with Rennie is usually when you report this, if it wasn't for Yapsy, this would already be fixed and released to cpan. He is incredibly fast. So this is a little timeline of BC to give you an idea. So in 1995, the announcement or the bounty was put out. 96 early alphas of the compiler went in. As best I was able to determine, the first appearance of the compiler in Perl shipped with Perl was 5005, and then in November 2003 562 came out. So that's the version cPanel has been using all these years. We're going on 11 years we've been using that, because in 5.10.0 it got taken out of the core, probably because it wasn't working on 5.8 and nobody wanted to fix it. So today on 5.14.4, which is a target we picked simply to move along the way to the latest Perl, it's mostly stable. Very likely with the next release of cPanel we will be building against 5.14.4, and maybe Rennie can stop sending patches to allow modules to work on 5.6.2. Today, okay, so I talked about some of this. So now, today, it's as simple as doing perlcc-e with the short program, run your a.out, or you can specify your Perl script in your binary, and it's going to generate that binary and run it. So there are optimizations where he's doing things to reduce the size of the C code. Some are more stable than others. We actually use -03, which is fairly aggressive, but you can turn that down and you can turn on and off individual options. In the past, what Malcolm produced and what was available in 5.6.2, what you actually had to do is do all this on your own, which is why it wasn't generally available to anyone. So you had to run Perl. So your first program here, well, the first one doesn't apply to the old one since it came with Perl. But you would have to run Perl with -mo, feed it to BC. That would generate the C file called coreio.print.c. And then the second one, this is actually what you can do today, but actually Rennie provided CC harness. What you then had to do was generate a .o file. I think it was a .o file, and then turn around and build your binary, do all your linking options so it would link to .libperl, so that it would link to all your XS SO files, and then you would have a binary you could run. So it's been greatly simplified since what it was in 5.6.2. Today, all you got to do is this, and you have a running program. So there are some things that we've talked about, but we descoped because we'd still be working on it if we hadn't. We want BC working on the latest version of Perl. We want compiled Perl modules. The idea was that our binaries are very large because they're having to compile in, most of them are compiling in all the same modules. So one of the ideas was that we could have 50 common modules that we are going into all our binaries. I could make an SO file based on those 50 modules, and then I could somehow tell the compiler that, well, it can actually pull these packages out and not compile them into the binary, but instead link to this SO file. The byte loader, that if I understand the byte loader, I don't really pay much attention to it. It's similar to what Python does, which is when you use a Perl module in Python, or well, it would be a Python module, wouldn't it? It produces a PYC file next to it, and the next time you use that module, it's using the compiled version of that module, in theory reducing your startup time. And finally, BCC, which actually would make your program run faster. It would do optimizations like, the idea would be you would somehow be able to hint to the compiler that this variable I'm going to use will only ever be an integer, and then instead of using an IV, it would be a C integer, and you could do more low-level math that would run faster. That's definitely way down the road for us. So if you'd like to get more information, you can go to irc.perl.org and watch the GitHub and Travis CI bots reporting updates, but I'm also in that channel, as well as Rennie, who is the active developer for this. This is our issues tracker. Here it's on Google Code because that was originally where we were doing source tracking. We've since moved to GitHub for the Perl compiler. You have the master branch with unstable changes that we're working on, and the release branch is the most recent thing released to CPAN. It's on CPAN, so you can go and take a look at it in the documentation. Anybody who wants to understand guts, I highly recommend going and looking at BC and looking at ILGuts, which is the illustrated guide to how different Perl variables actually are represented in C structures. And then you're welcome to email me if you have any questions or you'd like to get involved or get more information. That's all I got. Does anybody have any questions? Okay, thank you.